group, we went out into campus and we determined where exactly the storm drains were and their sizes and elevation with the ground. We wanted to do that because we wanted to see the overlay with the flow accumulation map in ArcGIS, which we would send to the civil engineering students. They would then determine if and what areas needed the most improvements.
My task was to walk around the campus and take measurements on the dimensions of the drains to help us understand how it affected the area around it and the water flow.
After we collected the storm drain data, we also collected parking lot data, like the dimensions, to see if engineers can plug in BMPs and also double check to see if the dimensions were correct. After we gathered all our data, we also used ArcGIS and a drone map to plug in all our data afterwards.
We made them do various tasks. One of them was measuring out the parking stalls, as we didn't have a plan of the school online, so we made one ourselves. So we needed a one-to-one scale, and their measurement was to just ensure if it was scaled properly. We made them take a drone footage, and it helped them with software to get arrows for the stormwater runoff, and that gave us a stormwater runoff map or runoff, and within that map we're able to see which areas would be populated with water, and that's where we would implement our BMPs. Some BMPs that we implemented there were R tanks, or like I said earlier, the infiltration trench, and their help was just made it easier for us to just figure out where exactly our BMPs could go within Whitehall High School.
So during our time of the project, we also made 3 maps representing different key points of what we observed or what we plotted data from our field trip.
In the first map, you can see blue circles and red lines. The red lines are high traffic areas where people walk on. They're all made of concrete, so it's not really much of a concern. But the blue areas are a concern because people still travel there, and since they're constantly traveling there, it ruins the terrain. So in Q quad, or the top circle, it's all mud because people are constantly walking there. So when it rains, all of the water that hits the ground puddles up and people just track mud across the campus. In front of the cafeteria, the gutters all collect right in front of the cafeteria. So when the cafeteria walkway gets crowded, people have to walk in the grass to get around them, which also ruins the terrain because people are walking there. The blue circle by E&F building is also another hangout. It's half mud, half grass, because during breaks, people will stand in that quad just talking and walking to class. The water doesn't get properly soaked in, so it just gets ugly. And it would make people want to either replace it with concrete, which would be the opposite of what this project is, to reduce the amount of runoff from concrete. So the blue areas would probably be areas that need to have their environmental landscape improved.
The green on the map, a lot of people hang out there and it's muddy and wet. The purple is the cafeteria. Yellow is I building, and a lot of people hang out there, and I noticed like a lot of mud on the walkways. The blue indicates the admin building, and it's really muddy like around the building and the walkway. The next time it rains, we expect lots and lots of mud in these target areas.
So for our third map, we used ArcGIS Pro, and we used a drone map which was given to us. We plotted the storm drains in order to get a better understanding of where, or to see if the storm drains are actually placed in the spots where there are a high concentration of flooding or low concentration of flooding. And the map can also show us like where we could like technically put more storm drains, so it would lessen the flooding on campus.
The main goal in our design was to maximize the stormwater credit that Waipahu High School would receive when it is implemented. From our calculations and the BMPs that we designed, we would be able to increase the stormwater credit to 50%, which would basically cut the stormwater fee that the school receives in half.
For the first slide for the civil engineering deliverables, we broke up the school into 6 different sections to calculate each drainage area, which would help us with later within the credits and breaking down the stormwater pathing. And on the next slide of the civil engineering deliverables, we have each building broken up, and we have the areas of each building as all buildings are impermeable areas, and we needed that to calculate the Q, or the flow of the water runoff. So on this table you can see that on the top we have the permeable areas, and then each building in Waipahu is labeled in letters, which is the A through Q, and we have also the admin building, walkways, and roadways and parking. And then at the end that's where you can see the flows within each building areas. And for the next slide, we have the BMPs that we came up with, which was the R tanks, infiltration trench, permeable pavements, and added vegetations. So each is labeled, and it's within the certain areas that correlate with what Waipahu High School students gave us from the stormwater pathing, and then that's where we put the best management practices, or the BMPs, as it showed that that's the area that had the collection of the water pools. Lastly, for the civil engineering deliverables, we have the weighted credit, and as we saw earlier before, it was broken up into 8 areas, and we have the type of treatment within each of the areas, and finally how much credit each of the area is actually gaining, with our total credit being 51.23%.
Based on John's scenario with facility development branch being one of our main targets, we have created a persona that was based on Waipahu High School. And before getting into the technical part, I will be going over the brainstorming along with the other stages that we've gone through and how we've come up with our envisions. Starting from scratch, our team used Miro to share and collaborate ideas using different color blocks, and after each member has filled their own blocks, those ideas were categorized and filtered based on our selections. And then during our meetup at Data House, we implemented the ideas from Miro and voted for the MVP. Those features were represented in a unified screen in the slide. Our team also used another platform called Jira to assign tasks and to keep track of our developing progress of each sprint. And let's our demo that Sam can start us off.
The homepage we have created is representative of CIMP project goal. The purpose of this website is for a user who is residential or commercial to be able to understand what stormwater is and how it affects their water utility fees.
The metrics that you see on the homepage were researched and displayed as another way of informing the user about the purpose of stormwater utility. People using this webpage for the first time could be uninformed about why this fee is exacted on their property. And these metrics really drive home the idea that Hawaii's water infrastructure is in critical condition. Moving on to the case studies. These are just some example articles that are relevant to this topic of stormwater in Hawaii. These articles also include pictures and links to the articles if users wanted to read more about it.
The FAQ page was made to answer frequently asked questions. We decided to create a user-friendly UI by categorizing different types of questions so it was accessible. Some types of questions include the general question where they ask questions like what is stormwater utility or how can we benefit and why it's important. Other types will include stormwater runoff, which will ask about what stormwater runoff is and why it's bad for the environment, as well as the fees and what is being calculated and how it's being calculated given the areas.
For this page, we also implemented a newsletter module, which was an idea from our ideation phase. It is now fully implemented as we do not yet have a source for the newsletter that we can use to deliver news and updates. But the idea behind it is, once we do have something, users can subscribe to the newsletter by inputting their email address so that they can stay notified on updates to the stormwater utility policies. The next page in our design process was the calculation page. This page uses a map interface for the user to input an address or location of interest and allows the user to calculate the stormwater utility fee of that property. The primary feature is the ability of the user to draw shapes on the map that can be labeled either impervious or pervious. This gives the user more insight on how impactful each impervious structure is on the stormwater utility bill.
Using the data given by the civil team, we were able to implement it in the Waipahu High School on our map. The future goals for this page is to then use the City and County Honolulu's property TNK data and have all of Oahu's property data be visualized. And that will be the end of our presentation. Thank you.
Overall, this was a great experience being able to work with teams from different areas and to implement our ideas from nothing to a complete prototype, and I'm really proud of our product and enjoy working with everyone.
I felt that the project was a great experience as I got to work and collaborate on a real-life problem with other students. Everyone was given an opportunity to work on different parts of the project as well as inputting their own ideas. I felt that we were able to support each other whenever we needed help, and I was able to learn a lot from both the project as well as my mentors and the team members that I can implement in my future.
Overall, this project was a lot more comprehensive than I anticipated, and there were a lot of design goals to achieve after our brainstorming sessions, but we managed to complete and implement many of them. Even though we were not able to complete all the pages that we had in our design process, I am very proud of how we did on the ones that we did complete.
I thought that this project was very challenging and it gave me great insight as to how to go about developing a website. And this experience will be very beneficial for my future career.
The most important thing that I enjoyed about this project was being able to collaborate with other members. This was my first project that emphasized the methodological process of creating product. It was interesting to gain real-world experience and being part of an important project that will benefit all of Hawaii.
So overall, the program was great. It was cool to collaborate with a whole bunch of people, as that's like what you would do in an actual real-world environment. Yeah, I guess as a senior within civil engineering, it was a good just setup for getting ready for the adult world and getting ready for my actual job. It was just very interesting to just collaborate with a whole bunch of people, with the Waipahu High School team, with the IT team, and just to see how we can each help each other out with the data that we collect and come up with like the things we would need for Waipahu High School for the design or for calculating the impermeable and permeable areas like the IT did. It was just a really fun project to do and something different from the other senior projects that I've seen.
My final thoughts in this CIMP is that I was able to work with the Waipahu High School students as well as the tech team, and we were able to collaborate together to solve a problem that Hawaii is facing and also get real-world experience in doing solving like a real problem versus in our classes we just solve theoretical problems. So it was nice to get that type of exposure and learn about those things. Also, from this experience, I didn't realize that runoff and the freshwater supply in Hawaii is such a big issue, but after doing all of these calculations, I realized that the runoff generated from the impervious surfaces has a very detrimental effect to the oceans and the rivers downstream. And also that as our population increases, we are going to eventually run out of fresh water if we do not replenish those resources.
Before the start of the program, I didn't really think of like where rain or like water would actually go. I just know it would probably end up in the ocean somewhere. But I didn't really get a good sense of knowledge of how it could really affect like not just the state but everyone as a community.
I think this program was great. I think it gave me a good amount of experience as to what civil engineers do, and I personally enjoyed it. I think it was really interesting about what we did and how we did it.
Throughout the project, I thought it was pretty interesting that schools were beginning to be fined for the amount of runoff that they had. So I thought that with like budget cuts or maybe like school funding, I thought that having to be fined for runoff is pretty expensive, I guess. So I think that this problem is pretty important, especially for Oahu or maybe like Windward side, since they get a lot of rain. So this could be definitely an interesting project that other people could invest in.